Alright, sound check. Pazartesi, Salı, Çarşamba, Perşembe, Cuma, Cumartesi. So yeah, this is a backstage recording of a demo that I'm going to do. Later down the line, I'll cut this in post-production and make it a shorter, more concise video. But this is like the raw recording. So I'll talk about what I am doing, and I'll explain things in more detail. So if you want uncut, unfiltered versions of a version of how we do some stuff with VMware Secrets Manager, then you are right on the right channel. I'll do this, so like enjoy it. If there are mistakes, I'll be trying to fix them on the go as well. So since this is a live demo, you might be seeing me like tackling with stuff as well. And like as a reminder for the chat on Twitter, Twitch, and also YouTube, I won't be paying attention to any chat at all because this is for the recording purposes. But feel free to chat along. Feel free to run discussions there. I'll look at them later. But for the sake of this demo, I'll just explain in a like plateau-like monologue fashion about what I'm going to do. That said, so in let me zoom up a little. Hello everyone. In this demo, we are going to explore a new feature that we are introducing to VMware Secret Manager, vSecM, which is the integration of ESO, External Secrets Operator, to VMware Secrets Manager. This means that we can mint secrets in VMware Secrets Manager, and any cluster can talk to a webhook endpoint that we create, which we call vSecM Scout, and they can talk to vSecM Scout, and actually external secrets operator ESO can talk to vSecM Scout and query VMware Secrets Manager, get the secrets, and reconcile them as actual Kubernetes secrets in the cluster that the external secret operator will be working on. So I'll show it. But since the feature is not as part of the main line yet, I'll have to build everything from the source, and I need to do minor adjustments. But overall, the feature is working fine, and I'll show and I'll explain on the go about how things work and dive into the source code a little bit. And also keep in mind that this is like initial phase. Later down the line, things may change. We may add more, I don't know, authentication strategies, more certificate rotation strategies. But this shows as a high level how VMware Secrets Manager external secret operator integration can work. So that said, let me go to the screen. So this I split the screen in two parts. But while doing the actual recording, I'll just show the right-hand side. This is more or less like a 1080p resolution, and the left is for my notes and like copying and pasting stuff. So what we are going to do is we are going to let external secret operator consume raw VMware raw VMware Secret Manager secrets, and then reconcile it as a Kubernetes secret on a random cluster, essentially. For that, we need to expose a secure endpoint so that it can be queried from any external cluster. And one way to do it is to use a webhook endpoint that external secret operator can query. And to do that, we need to establish secure communication. So we need to create certificates, and we need to have a way to authenticate the client as well. For authentication, we'll do JWT authentication, JSON Web Tokens. The reason we do that kind of authentication is because if you use JWT, you can extend that logic to any other authentication provider, like Keycloak, for example. Keycloak can create JWT, and we can dispatch those tokens, and the requester can use those tokens essentially. Or like any identity control plane is typically able to mint JWT tokens, JWTs actually. So that's one way to do it, and that sounded the most plausible way, the most cloud-friendly way to do it. So we started that way. But later down the line, we can establish other authentication strategies as well, including SPIFFE MTLS. But for the sake of simplicity, SPIFFE MTLS is not there. It's just one-way TLS secured by JSON Web Tokens. So that said, like let me start to like go through what I'm going to do. So I have my VMware Secrets Manager's repository here, the entire source code. So I need to build it from source because the binary, the vSecum Scout binary has not been pushed to GitHub yet. Sorry, Docker Hub yet. This is pretty new, but it will be part of a VMware Secrets Manager component later down the line. But first, I need to do I need to create a component to be able to use it. So what I'm going to do is first I'll install VMware Secrets Manager to the system. Then I'll build the component as a container image, the vSecum Scout, which is the webhook endpoint, which will be a container image that we are going to use. After that, we are going to create a bunch of certificates to secure the authentication. Part of those certificates will be passed to vSecum Scout as VMware Secrets Manager minted secrets. So they won't be even Kubernetes secrets. It will be even more secure than using plain Kubernetes secrets, because you cannot see those secrets unless you have access to VMware Secrets Manager. So that's one thing that we are going to do. Other than that, we are going to install external secrets operator. Then we are going to do some load balancer configuration to establish networking, and eventually we'll show how we can reconcile a Kubernetes secret first by reading it from VMware Secrets Manager and deploying it in a cluster as a secret using SO. So that's that one, and let's start with the first one. To install VMware Secrets Manager, there are several ways. The most recommended way is to use Helm charts, but we cannot use Helm because the workload that we are using is not there. So as an alternative, I will use the make commands. Initially, I'll delete the current demo cluster I'm working on, so that any remnant configuration is gone, and we start with a clean slate. So I'll do make k8s delete. This will remove the minikube cluster that I'm working on. Let's see. In the meantime, and then I am going to do make k8s start. It will initialize a new cluster. It will take a while, but not too much. Okay, let's see if we have the cluster. Kube-get node. I have my cluster. I'll do some extra initialization to point to the proper Docker registry. And now I'm going to build VMware Secrets Manager from source code to get the binaries that are not in upstream yet. So for that, I'll do make build local. This will take a while. Actually, while it's doing that, I can go through the source code, I guess. Let me bring that in. I'll just close everything down here. So we have a bunch of things. The main change that we are introducing to VMware Secrets Manager is what we call vSecond Scout. Scout is a webhook endpoint that external secret operator will use as a secret store fetching connection, or like an external secret operator secret store will use this webhook endpoint to fetch secrets. So this is a webhook provider in terms of SO lingo. So this is the main function. I'll just briefly go through it because it's things are building in the background anyway. So let's leverage the time that we have. So here we are fetching a bunch of secrets from VMware Secrets Manager itself. The sentry.fetch is a VMware Secrets Manager SDK utility. So it returns a sentry fetch response, and those secrets are the secrets that the external secret, the vSecond Scout SO webhook is required to use for initializing a secure connectivity, for example. So it's doing it's the code is rotating around the range of secrets that it fetched from vSecond safe, and we establish a just secret in memory. We record it in memory. We create a server secret, server key. These two is used for TLS connectivity. This JOT secret is used to verify JOT tokens, and we do some basics for decoding because the secret come in basics of 64 form, and after that we create some TLS connectivity. So we have a TLS configuration down here that we will be using those certificates that come from the secrets to establish a TLS enabled server. And if you see, there is more configuration that we can use, but I wanted to keep it simple for the sake of this demo. Maybe later down the line, based on environment variables, we can configure other things like the preferred cipher suites, or whether to disable TLS negotiation to make a vSecond Scout endpoint even more secure. But for now, this at least is TLS provides TLS security for the demo purposes. It is secure enough. So then we delegate the flow to a webhook handler. The webhook handler does a bunch of stuff. It does JOT validation, and also it checks if everything is in good shape, and then it fetches a query string essentially, and it parses that query string. That query string is in the form that is expected from an external secret operator client. From that secret string, it gets a key and a path. I'll show what that key and path entails. Let me briefly switch to where is that? Update vSecond. So in this script, I'll come into that soon, but we create a JSON secret for VMware Secrets Manager. So this is for this Coca-Cola tenant, supposedly in this cluster, we want to associate this JSON as a secret and to be stored in the VMware Secrets Manager safe. So what that path is, it's a path to query within this secret essentially. So let me put a comment down here. An actual curl to that will look like this. So it just, let me move it downwards. To the webhook, I'm going to send this cluster and tenant combo as the key, and this is totally configurable. I'm using this just as a convention, but it can be any string as a key. This is a secure key value store essentially, and the path is from, let me mark it, namespaces, Coq system, secrets, admin credentials, value. So it will go to namespaces, Coq system, secrets, admin credentials, and value, and there it will fetch this value and display as a result. I'll do the curl when I install everything, but right now that's good enough to explain how it operates, I guess. So there's some logic here. It is just an initial attempt at it, so it might not be perfect. But like, actually, let me show you the like function. It's just like doing a for loop and doing some key value matching. For the sake of efficiency and simplicity, we are not using a JSON query like library. We may prefer to do it later down the line. I haven't thought about it too deeply, but right now it's just simple tree-like path matching without any specific query complexities, which may also introduce security complexities. So keeping things simpler, at least initially, is a better approach, I guess. So that's fun. Let me go back to like other things. Like we have this hack folder, for example, to that we can use to initialize things. I'll show the code later as well, but let me go through it right now again. So we have like a metal LB configuration. This is like simple minikube metal LB, nothing fancy there. We create a bunch of certs. So this is like this emulates how the day zero operations work. Like essentially, we won't be likely using a secret. A human operator might be creating this. We might be getting these certificates from a certificate provider that we trust, maybe. But for the sake of this demo, we are creating a bunch of certs down here, and then like we are saving them and like moving them to a folder that we are going to reference later. These are all for TLS security, and also we create a cluster secret store custom resource. Again, this is just for the sake of demo. Ideally, it might make more sense to create an operator or some custom controller to create this secret store so that it will be more streamlined. But for the sake of the demo, creating this as part of this initialization script works fine. How this secret store works is it will talk to our vSecure Scout endpoint in a secure way. And how does it establish security? The TLS security is done by the CA bundle that we create down here. And since this CA bundle is like public crypto material, we can pass it over the wire, and we can configure, and another external operator can configure it like separately. There is no security leak in passing it through, essentially. Again, there is this bearer token. This token is, again, relatively secure. You can pass it as plain text. There is nothing secret in a JAT token. The validation of the token is done on vSecure Scout service, and vSecure Scout service has the key to this token to validate it. So what I mean is we can pass this one and this one in plain. There's no harm in passing them in plain text. So we can store these in source control as well, like a mini Git repository that can then use something like Flux to reconcile everything. So those are some ideas. Like it will depend on your GitOps model, but there are many options that you can create this CR and deploy it to the cluster that you want to deploy, essentially. Right now, for the sake of simplicity, we are just creating it and copying it over and like manually deploy it, as you'll see in the later part of the demo. This Docker build will build the vSecure Scout component. It is just like bundling everything here, bundling everything here and making it a nice container image. Install SO is like installs external secret operator from Helm charts. Other than that, let's see. There is this update vSecure. I just briefly showed it. So what it does is it reads the certificates that we create in the former step, and then it creates VMware Secret Manager secrets. These are not Kubernetes secrets. These are secrets that are stored in VMware Secret Manager safe, and it is impossible to reach unless you have authority to read it. So you cannot like you cannot do kubectl get secret, for example, and get those secrets. These are stored in the memory of vsecond safe, and when they are backed up in encrypted form at rest. So it's really hard to get them and decipher them. So we create a bunch of secrets that external secret operator will leverage, and we create a sample secret for our supposedly like tenant, which is Coca-Cola, but Coca-Cola is just an example. It can be anything. I just didn't want to say like tenant 0001 or customer 005, something like that, because I wanted I want this demo to be meaningful, but I don't have any like association or affiliation with Coca-Cola. It's just a sample tenant essentially. That's that one. So then what we do is we create a JOT token with a mini Go utility library. Let me show that one as well. Token.go. It's just a couple of lines of code. We create a vsecond Scout client minted token, and like we serialize it and return it as a response. And based on that token, we create a secret. This secret again will be used by the cluster that is going to talk to the vsecond Scout external secret operator webhook endpoint. So what it will do is it will the cluster where the secret store is will reference this secret and use the token here to authenticate itself to vsecond Scout, and it will be able to fetch secrets here this way. Otherwise, it won't be able to successfully fetch those secrets. But those are like what we have at a high level. I'll go. Actually, let me go through the like deployment manifests as well. So we have one external. Sorry, let's see. One manifest for external secrets operations, and the other is for like vsecond Scout entities. Let me start with vsecond Scout. We have a deployment that is like pretty typical. The only thing that might be interesting could be this SPIFFE endpoint socket, which is used to fetch the SPIFFE SFIT, SPIFFE bundle from the SPIFFE workload API to be able to securely talk to vsecond safe to fetch those initial certificates and secrets to bootstrap the service, and also it is used to fetch any other secret like the custom secret that we registered to the cluster. This identity.yaml is a cluster SPIFFE ID which secures the vsecond Scout itself. So unless vsecond Scout has this SPIFFE ID and it is identified by like vsecond Scout, and it is in these namespace with these labels, it won't be able to talk to VMware Secrets Manager safe and fetch the secret it is entailed to fetch essentially. This is like identity essentially. Somebody defines this ID, and with that ID it can talk to vsecond safe. The other is this service is to expose vsecond Scout outside. In a single cluster, it's not needed, but in a federated cluster structure, we'll need to expose it. Right now, we are using Metal LB as a load balancer, but in a production deployment, it will be likely something like, I don't know, Istio ingress gateway or some other ingress kind of a sort. But essentially, as long as there is a network connectivity, things would be good. And this is a service account to establish security. If you remember, this service account is verified here as well, and it is also verified in other places. So without that service account, our vsecond Scout workload won't be able to like establish its functionality. So this is an additional security measure as well. So we have an external secret here. What this secret does is we pass a key as a remote reference to the secret, and I want with that key we want to interpolate what is called a password, and those password is interpolated in like several places. You see, just for the sake of demo, there might be like more key value pairs here as well. I just wanted to keep it simple, so I'm just passing the same password everywhere, which doesn't make practical sense, because for a label you would prefer like maybe managed by VMware Secrets Manager, or for annotation this should be like inject sidecar true false or something like that. But for the sake of simplicity, it is we are passing the password, and we use the same query like for Coca-Cola cluster 001. I want the value, whatever the value here, that is defined for that workload. So this this workloads associated secrets, this like value will be passed as the password secret key. So essentially, like we'll query the TLS endpoint, the webhook. We'll get the value from that big JSON that you might have seen. Let me show it again down here. So from this JSON, we'll get the super secret, which is all the way down here, like admin credentials, Coq system, that value, and we then display, we then reconcile it as an actual secret. And you can see we are not only displaying the secrets, like updating the secrets data, but we are also creating labels and annotations for the secret. So we have full control over the kind secret. We can reconcile it based on items that we query here, which makes external secret operator powerful, and which also adds extra power of this vSecond SO integration as well. So that's that one. Let me see that's what I did. I built the binaries recently. Now I'm going to deploy VMware Secret Manager to the cluster. Make deploy local, enter. It will take a while, not too long typically. There was a question, are tokens used only once for creating secrets? So the JOT token, this is a demo, so we are using this demo uses a long living, like a month long JOT token, but the token is supposed to, like if it's a JOT token, like it's a JOT, it's supposedly need to be designed to rotate relatively frequently. For that, we would need a controller, but that's beyond the scope of VMware Secret Manager. So whoever is managing that JWT will be responsible for rotating that JWT and also recreating the external store entity, essentially. So those are, in short, those are not one time only. They are. This is for just a single token creation. Also, like everything that I create, consider them rotatable. Like I create single certs, but those certs in an ideal world, you might want to rotate them like every 3 months or so. But whenever you do that, you need to do some reconciliation. And like if you think of it architecturally, you might want to have a like controller, like a Kubernetes operator to do it, or a human operator, depending on how you want to operate. But like for the demos purposes, it's a single certificate, single token. And that also goes for the JWT secret. even if it's near and dear and it's stored in VMware Secrets Manager, you might want to rotate it every once in a while as well. So that's that one. What did I do? We deployed it. Let's check if everything is in good shape. kubectl get pod -n vsecom system. VMware Secret Manager is up. Get pod -n Spire system. Spire agent is up. kubectl get pod -n Spire server. All right, everything looks good. So next up, I am going to build the vsecom scout image. So for that, where am I? Let me go a couple of layers up. I am in the folder that I want to. Cat hack Docker build. We have seen this, but just for the sake of reiteration, we are just building the source code essentially. So let's run it. Hack Docker build. Oh, thanks for the follow, by the way. I'll wait for the animation to finish because I'm going to cut out a bunch of these in post-production because I'm recording this as a material for a shorter demo. So okay, we have the container image. Next up, we are going to create the certificates. Let's let's look into this script once more. We create a set of certs essentially, certificate. This is essentially a self-signed cert creation, and based on that, we create a cluster secret store that refers to CA bundle, and also refers to JAR token that we'll create later. But that's the overall script. Let me exit this one. Hack create certs. By the way, I'll push all of these to open source. This is part of VMware Secrets Manager repository. So if you go to https github.com VMware Tanzu Secrets Manager, and from there navigate to examples folder, you will be able to see it. It's not there yet because it's part of a PR, but it will be merged. So it will be there by the end of today, I guess. You can just see the source code and play with it yourself. So that's that one. We created the secret store. I want to just move it to cluster secret store to Kate's external secrets because we are going to create it there. Do I need server conf? No, I don't need it. I can just remove it. Remove server conf. Clear. What else? We created certs. Let's install external secret operator because we need it. Typically, the external secret operator, in a multi-cluster use case, it will be in a different cluster. But since I have a single cluster, I'll install it on this cluster itself. For the sake of a use case, the use case in my mind was to have two clusters and let them talk to each other. But this is also representative enough. We have we can split it to different clusters. As long as there is network connectivity, it doesn't matter where you install ESO. Hack. And it's just we are installing ESO from Helm. Let's do it. Hack install ESO. No, you can write in Turkish if you want. It's fine. Like I said in the beginning of the recording or in the beginning of the stream, I'm doing this as a pre-production. I'll create a shorter demo video based on this recording. So this is just backstage. So feel free to write in Turkish. I'm I will answer in English, so that would be the issue, I guess. But other than that, that's totally fine. And in the streams that I am like speaking Turkish, I typically I do Turkish streams more than the English ones. So like when I'm speaking Turkish, obviously you can write in Turkish. When it's English, still you can write it. Worst case, I can just ignore it, but nothing else. Like I won't kick you out or anything. So that's that one. What did I do? We installed external secret operator. Now we'll create the secrets. Actually, we'll put the secrets that we need into VMware Secrets Manager so that vSecond Scout can bootstrap itself. So to show you the code again, where is it? Main. Dun, 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 dun. So here it's fetching the secrets, but still, again, this is like early development. In an ideal case, instead of this one-time for loop, uh, I am going to do this in a like busy wait loop. Like, hey, is my secret ready? No, okay, let's wait and like do it again. So because otherwise, when we call sentry fetch, this will return. If we haven't created those secrets, it will return nil, and the server will crash. Instead of crashing, it will make more sense to just like wait until the secrets are there, maybe. Or it depends. If you treat your pods like kettles, then it might make sense them to like uh, destroy themselves and revive until there's something that they need. But it kind of also unnecessarily consumes like cluster resources. So if it can wait and it can get eventually what it wants, then why kill it? Why kill it? It is if we know the eventual fate, I prefer for it to wait than just unexpected to crash. I prefer something to crash when that thing is like not expected. So if I'm expecting a secret to come eventually, I'd rather wait than crashing the pod, essentially, if it makes any sense. So that's that one. Let me move back to the terminal. So what we do, we install the external secrets operator. We were going to register the secrets, and that is update with second script. So there, to go over the code again, we are creating a bunch of, we are putting the search that we created into variables, and then, come on. Then we are creating VMware Secret Manager secrets, including the secret that we want our fake tenant to consume. So this secret is the secret that the external secret references, and these secrets that are down here above are the secrets that VMware Secret Manager Scout uses to operate itself, essentially. But we'll need all of them, so let's create them. Hack update vSecond. Ding, 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 ding. We have all those secrets. And we also created another jout secret YAML. So I am going to copy this vSecond scout jout secret to Kate's external secrets too. And let's see, I have almost everything I need. I need to create two namespaces. One of them is create ns coq system, and the other is vSecond. Was it vSecond client? Let me create it. I'll double check it in the source code. vSecond client. Yeah, that's vSecond client. All right, I created that namespace. Oops. That namespace as well. Okay. let's see. So we have the namespaces that we need. I am going to log get dash vsecum system. Log what's happening in. Oh, we haven't installed vsecum scout yet. Let's deploy vsecum scout. Then I'm going to log its logs down at the second terminal so that we can see what's happening behind the scenes. So for this, I'll go cd Kate's vsecum scout. I have a bunch of stuff. The service and service account are, typical. I'll just go through identity YAML again. Cat identity YAML. So we create a cluster SPIFFE ID for the workload if it's in these namespaces, and if it has these label selectors, it will be assigned an identity to be able to talk to VMware Secrets Manager safe. This is how typically vSecum safe authentication happens. So if you are a workload, you need to have a cluster SPIFFE ID to fetch secrets from VMware Secrets Manager. That's the operational model of the of vSecum essentially. Other than that, let's do a cat deployment YAML. It is like a fairly plain deployment. There's not much fanciness going around. We have labels, label selectors, and just one image, which is vSecum Scout. And even this endpoint, if we don't define it, I think, but I am not sure, it will automatically, VMware Secrets Manager Go SDK will automatically assume it is this one if you don't define it. But I prefer to be explicit. That's why I define that one explicitly as well. That's that one. So let's deploy them. kubectl apply -f everything. So let's do kubectl get po -n vsecum system. And now we have scout here. So I'm going to tail the logs. kubectl logs vsecum scout -n vsecum system -f. All right, we have a server up and running. So let's hope it continues like that. I'll go back. I'll go to external secrets folder and I'll create stuff one by one instead of doing a blanket kubectl apply to show gradually how things happen. So first I'll create this vsecum scout JOT secret. Let me show how it looks like. vsecum scout JOT secret. It's a base64 encoded JOT token that the webhook will use. So you need to specify this external secrets type webhook, otherwise SO will refuse to use it as a resource. Other than that, it's like regular opaque Kubernetes secret. And again, storing this secret in a Git repository is safe because this JOT token is not sensitive in itself. You can just decode it, and there's nothing there's nothing critical that you need to secure in it. That helps the operations, helps your operations if you want to do some GitOps with it. But yeah, let's create that one. kubectl apply -f vsecum scout JOT secret. So we have that secret. Other than that, we need a cluster secret store. Let's check its definition as well. Cluster secret store. Again, like this CA bundle is a base64 encoded public trust bundle. You can securely store this entire thing in a repository, and you can use your GitOps flow, whatever you use. It can be Flux, it can be anything to distribute this cluster secret store to any cluster that you want. That will depend on how you manage your Kubernetes fleets, but overall, this is safe to distribute across the wire within reason. Of course, you don't want to publish to the entire world. But if it's within your pipeline, you can securely dispatch it. Other than that, it is referencing to the token that we created. I don't know if you rotate the secret, if the CR will see it and rotate it itself, or like you might, when you rotate the secret, you might need to kill this CR and create another one. But still, it will be a single operation in the end of the day. But yeah, that is the custom resource. Let's deploy that one as well. Kubectl apply -f cluster secret store, enter. And I'm getting a TLS handshake error. That's strange. I wasn't expecting that. Hmm. Okay, let's see. If this doesn't work, it will become like a debugging session to figure it out, essentially. Kubectl get cluster secret store. Mm. Okay, it's here. I don't know about this TLS handshake error. I'll check into it. But I am hoping if I kubectl, if I deploy this external secret, either things will work or I'll have some evidence to debug things, because before doing this like live demo, I did a dry run and everything was working. So things should be close. I might be missing something. I might be missing an annotation here, a variable there, but we'll figure it out, and it will be better to do this in live stream, I guess. I don't know. We'll see. Let's check this one. So it is a typical external secret that is referencing a remote secret key reference and like a remote secret store. So I'll deploy that one as well. Kubectl apply -f vsecom scout example secret. Let's do kubectl get external secret -a. And yeah, so I don't know about these TLS handshake errors. I'll debug and diagnose it specifically, and I might make a separate stream about why this happened. But in the end of the day, I can see that the secret has been created and reconciled. So I'll let's check the actual secret, because this was the kind external secret, but we don't know the kind secret. So let's do kubectl get secret -a, or let's see all of the secrets that we have, and we have the admin credentials that's in the Coq system namespace. So let's check it out. Clear kubectl get secret admin credentials -n Coq system -output YAML, enter. So yeah, we have our secret here. Let's see it. It's here. I'll pick a different color, yellow maybe. So it is a external secret where you can see that by these annotations. It creates a SHA hash to manage reconciliation. But other than that, these labels like this managed by super secret, which doesn't make sense, because this is the secret. It should be a different label, but for the sake of the demo, it shows that we can create labels and manage labels from a separate upstream secret store, which is VMware Secrets Manager, and reconcile it to a secret that can be anywhere, including in a separate Kubernetes Kubernetes store, separate Kubernetes cluster. Again, now we create annotations, and also we actually created the data portion of the secret as well. So let me decode this to show you that it is a secret that we have initialized, base 64-D, and yeah, it is a super secret. So now we have a minor glitch about the TLS handshake, and it can be something specific to SO itself as well. Maybe while it's doing initial connection establishment, it does something that our service doesn't like. But like I said, I'll debug it and I'll diagnose what's happening. But other than that, I think it went pretty well. We were able to, with the help of VMware Secret Manager Scout, we were able to create a secret in VMware Secret Manager and let external secret operator reference that secret and do query on the attributes of that secret. The secret was a like a large JSON structure, and we were able to pick a value, a leaf value in that JSON tree, and assign it as labels, annotations, and also secret data to a Kubernetes kind secret. So we were able to dynamically interpolate this. And the beauty of it is, like, whenever we change the secret in VMware Secret Manager, the external secret store will query it and reconcile it and change the secret in the cluster without us having to like ripple this manually. So that's the beauty of external secrets operator. And the benefit of VMware Secrets Manager is it will store that sensitive secret in a much secure way than a like regular Kubernetes secret, to be honest. So that's an extra level of trust, an extra level of peace of mind that we get out of VMware Secrets Manager. So we kind of get the flexibility with SO and security with vSecOm to get the best of both worlds. But as far as this demo is concerned, that's all I have to share. Until next time, keep your secrets secret. Okay. Yeah, I think I'll cut it out. This was a short, relatively short recording. Like I said, I'll create a post-production cut of this one and like have a relatively shorter demo recording, and I will passively stream this one as well, so you can enjoy a shorter, more condensed version of it later today. But that's all I have, and like it's almost post lunchtime, post breakfast time, so we'll have a brunch because I didn't have breakfast as well. So we'll enjoy some family meal, and hope to see you around. Have a great day, and like I said, keep your secrets secret.